Section 6.1, example 2, graphing a function and partial sums of the power series. So sketch the graph of f of x is equal to 1 over 1 minus x, and the graphs of the corresponding partial sums for n equals 2, 4, and 6 on the interval from -1 to 1. Comment on the approximation as n increases. Ooh, okay, so let's give this a shot. So before we graph it, we have to figure out what the function actually is. So we have f of x, that one's easy, it's given to us. F of x is equal to 1 over 1 minus x. Let's look for s sub, they want us to look for 2, 4, and 6. So what we're doing is following this right here. S2 is this stopping at the number 2. So the sum as n goes from 0 to 2 of x to the power n. So this one ends up being, when x is 0, we have 1. Plus when x is 1, we have x to the power 1, or just x. And we stop at 2, x to the power 2. And that's what we have right there. Let's look for S4. So we're looking at the sum as n goes from 0 to 4 this time, x to the power n. So starting off at 0, x to the power 0 is 1, plus x to the power 1, plus x to the power 2, plus x to the power 3, plus x to the power 4. And lastly, we're looking at s to the power 6. We kind of get the picture now. So we have 1 plus x squared plus x cubed plus x4 plus x5 plus x to the power 6. And now let's get to graphing. Just a sec. And I'm back. So let's see what these graphs look like. So first, starting off with s sub 2, I'm going to do the sums, and then we'll see this one at the very end. So s of 2 is this one right here. Okay, cool. And we're graphing it from 0 to 1. I just wanted to show you a little bit more. And we could scooch this over just a tiniest bit. The next one that we're going to look at is s of 4, ends at x to the power 4, which is this one here. And it's above the one that we just did on its interval. Kind of cool. Next is going to be s sub 6. This one is graphed in the green. And let's see what that looks like compared to the function that we have over here. Ooh, so as we look at all of these values, s sub 2, s sub 4, s sub 6, as s gets larger, or as n gets larger, it gets closer and closer to our actual function. Our f of x is equal to x minus, or 1 over 1 minus x. It gets progressively closer to that one, so much so that if we look at the infinite sum, it actually is this graph right here, which is kind of cool. And that's about it. If you have any questions, please feel free to ask. Otherwise, bye.